Hello. In lesson 1, we learned what is SOHCAHTOA and how to use it to find missing angles of a right angle triangle. In this new lesson, we are going to use SOHCAHTOA to find the missing sides of a right angle triangle. But before we start finding the missing sides, we can first revisit the basics of SOHCAHTOA. We said any place in the formula where you see O, it stands for opposite, which is the side directly opposite from the angle we are given. Then when you see A, it stands for adjacent, which is the side that interacts directly with the angle we are given. And then H stands for hypotenuse, which is the longest side of the triangle. Then from there, we said S stands for sine, which is the sine of this angle here, which we are given. And then cos, C stands for cos, which of course is the cos of the angle. And then T stands for tangent, which is the tangent of this angle here. So let's say, for example, if you are given the hypotenuse, which is 2 centimeters, then you are taught to find the opposite, and then you are given the angle as 13 degrees. What you are supposed to do is, you look for the two sides which you are given. In this case, you are given the opposite, and then you are given the hypotenuse. So it means we have O and H. So we go back to SOHCAHTOA, and we look where O and H appear both in one set. So in this case, if we start with sine, you'll find we have O and then we have H. In cos, we have A and H, but so meaning in cos, we only have H, we don't have O because we have A. Then in tan, we have O and A, meaning we don't have H. So the only place where O and H appear the same is in sine, where we have O and H. So it means then, to get the opposite here, we are supposed to use sine. So to use sine, we are going to find the sine of this angle, and the sine of that angle is given by sine theta, which is the sine of this angle, is given by opposite, which is this O, divided by hypotenuse, which is this H. So from there now, we need to say sine 30, which is the sine, of course, we are given 30. So the sine of 30 is given by opposite, but we don't know the opposite. It's the one we are finding, so I just put a question mark and divided by the hypotenuse, of course, which is 2 centimeters. That's why I put 2 centimeters there. Then from there, of course, it becomes easy because I just need to cross multiply. This 2 becomes here. So now it becomes 2 multiplied by sine of 30 is equals to the opposite. But we don't know the opposite is the one we are trying to find. So from there, we can go to the calculator and find the sine of 30 degrees. So if I have the calculator here and just say 30, which is the angle, then I click on the sine. So the sine of 30 is 0.5. So now that we know the sine of 30 is 0.5, and we were multiplying it with 2, now it becomes, the opposite will be 2 multiplied by the sine of 30, which is 0.5. So it becomes 2 multiplied by 0.5. Then from there, of course, 2 multiplied by 0.5 is 1. So the opposite becomes 1 centimeter. And that's how we have used sine to find the opposite of this right angle triangle. How about if we are supposed to use cos? Let's try. Let's see. So now, still with the same angle, let's say we are given the hypotenuse and we are given the adjacent. So the adjacent is √3 centimeters, and then we have to find the hypotenuse, but we are also given the angle, which is 13 degrees. So from there, of course, we have the hypotenuse, we have the adjacent. So we go back to our SOHCAHTOA formula, and we see where adjacent and hypotenuse A and H appear at one group. So in this case, they only appear at here where we have cos. So adjacent and hypotenuse at no other place where they appear both as a pair. So then it means for us to get the hypotenuse, we are supposed to use cos. So we are going to find the cos of this angle here. So now the next step should be, we say the cos theta is equals to adjacent, which is this here, divided by hypotenuse, of course, which is the h. But you see, we already have the adjacent, which is root 3 centimeters. We also have the angle, so we can get the cos of the angle. But now we asked about the hypotenuse, so it's the one we are supposed to find. So the next step then is cos 30, which is the cos of the angle we are given, is equals to root 3, which is of course the adjacent we are given, which is root 3 of course, then divided by hypotenuse, which is the one we are trying to find. Then from there, of course, we just need to cross multiply. We can just cross multiply here. Now it becomes, of course, this hypotenuse which we are trying to find multiplied by cos of 30 degrees is equals to root 3. So to get this hypotenuse, we need to divide both sides by cos of 30. So it becomes root 3 divided by cos of 30. So if we go back to our calculator, you'll realize that if I take 30 and then I find the cos of 30, it will be 0.866. I just rounded off to 3 decimal places. So from there, since we know the cos of 30 is 0.866, then it means the next step I can just say, take root 3, then I divide by the cos of 30, which is 0.866. So if I come back here and then I take root 3, then I divide it with the cos of 30, which is 0.86626, so it becomes 2.000, which is, when I round off to one significant finger, it becomes 2 centimeters. So it means then this hypotenuse is 2 centimeters. How about if we are supposed to use tangent or tan to find any missing side of this triangle? How do we go about it? So let's say, for example, we are given the opposite, which is 1 centimeter, and then we are told to find the adjacent, and then of course we are given the angle, which is 30 degrees. What we are supposed to do is, of course, we find the sides we are given. We are given opposite, which is O, and then adjacent, which is here. So we go back to our SOHCAHTOA formula, and we look where opposite and adjacent appear as a pair. So in this case, O and A. And they only appear in tangent because we have O here and A. At no other place do they appear as a pair. So, since now we know they appear in tangent, we are going to use tangent of this angle to find this missing side here. And how we are going to go about it is, we start with, of course, tan theta, which is the tan of this angle which we are given, is equals to opposite, which is the side we are given as 1 centimeter, divided by adjacent, which is the side we are supposed to find. So now from there, we can go next and say tan of 30 degrees, which is the tan of the angle we are given, is equals to 1, which is the opposite, of course, the whole, then divided by the adjacent, which is, of course, the question mark because it's the one we are supposed to find. Then from there, we can just cross multiply, and it becomes question mark, which is the adjacent we are supposed to find, multiplied by the tan of the angle we are given, which is 30 degrees, is equals to 1 centimeter. And just cross multiplied to remove this question mark here. So to get the adjacent, then it means I'm supposed to divide both sides with the tan of 30 degrees. So it becomes 1 divided by the tan of 30 degrees is this adjacent here. So if I come back to the tan of 30 degrees, can just come back here and say 30, which is the angle, tan is 0.577. But 0.577, if I take now 1 divided by 0.577, I may do it. If I take 1, now I divide with the tan of 30 degrees, which is 0.577. Now it becomes 1.733, but 1.733 is just the same as the square root of 3. Let's confirm that. If I take the square root of 3 from the calculator, let me see. I have 3, then the square root, it becomes 1.732, which is almost equivalent to the same as 1 divided by 0.577, which was, of course, our previous answer. So, it means then, this adjacent here, it becomes root 3. So, that's how we use sine, cos, and tan to find the missing sides of a right-angled triangle. If there is a place you did not understand, you can ask me in the comment section. I'll try my level best to answer. And let us meet in the next lesson where we are going to learn a different concept in mathematics. Bye for now.